Okay, this short video is recorded by Dr. Shan to show you how to conduct Gage R&R in Minitab and linear regression Okay, so first let's do the Gage R&R. We open our data. Okay, so it's GAGE underscore example. Okay, so after you open the data in Minitab, you should inspect the raw data, to make sure that it matches our description. Okay, so in this sample study, we the first column corresponding to parts, right? So you can see we have 10 parts. Okay, and we have column 2 corresponding to operators. So we have 3 operators, and each of the operator will measure the parts 3 times. Okay, and they will measure all 10 parts. Okay, so that means operator 1 will measure part 1 to 10, and the operator will do 1 to 10, and the column 3 corresponding to measure. So we know that we need to use cross design, right? Because one part is measured by, each part is measured by all the 3 operators. So we go to quantity tool, go to gauge study, and gauge study crossed. Okay, now in this pop-up window, you can see the cursor is in the parts number. Okay, so you double click part, so the first column corresponding to part number, and then you double click, the cursor goes to operator, and you double click operator, so you also automatically entered, and finally the cursor go to measurement data, you double click measurement. Okay, so the method of analysis by default is ANOVA, so we will use ANOVA, and you can hit OK and wait for it to conduct the analysis. Okay, so here is the output. I also gave a screenshot in the presentation. Okay, so we said that the PowerPoint have a detailed description of all the explanations, right? So briefly, we can see that majority of the variation is due to parts. Okay, and also due to parts, and there's some portion due to repeatability, due to the measuring instrument, due to some portion due to the reproducibility. And you have 2 columns, one corresponding to contribution and one corresponding to % study variance. Okay, and the contribution, they will add up to 100%, and the study variance does not, right? So we have 2 different rules for that, for both of them. And if you look at the measurement part by part, the horizontal axis corresponding to 10 parts, and the reason that you see multiple dots is because they take several different measures, 3 different measures of the same part, and there are 3 different operators as well. Okay, so you can see, ideally, if there is no variation from the measuring instrument and the operator, then they should be on top of each other, right? But here you can see some small variation. Okay, and then you have the measurement by operator. So in this here, we just separate the 3 operators. We can see there seem to be the variance seem to be the same amount, and the mean value by the 3 operator is slightly different from each other. Okay, and finally you can see the interaction. So we will talk more about the interaction when we talk about the ANOVA. Basically, it just to help you to see if the operator make a difference when you measure a particular part. Okay, so if there's no interaction, the 3 line, blue, red, and the green, they should be on top of each other. Otherwise, if there is interaction, there will be a different pattern for A and B and C. So suggesting that, let's say that measuring part 3, the measurement will be different, depends on who measure it. Okay, so that's what it says. And R chart basically is X max minus X minimum. It's the range, and the X bar is the average measure, right? So this is more extensively, those are typical control charts used in the control phase, which we will talk about later. Okay, thank you. And the numerical output. So if you look at, we can ignore this ANOVA part because we are going to talk about it later. So if you focus on the Gage R&R part, the first part is the variance component. So break down the variance into different components, different Gage R&R, which include repeatability and reproducibility, and also the part-to-part. As you can see in the slides, we also mentioned that because the total contribution due to Gage R&R is 7.76, less than 9%, so we say that it may be acceptable. So ideally you want it to be less than 1%. Okay, and then if you go to gauge evaluation, you will look at the study variance, and so the rule that is if the Gage R&R is less than 30%, we say it's maybe acceptable. So which is this case here. Now if it's less than 10%, then it's definitely acceptable. And finally, let's take a look at the number of distinct categories. So we want this number to be as large as possible, meaning that the gauge system will be able to differentiate one class from another class. Okay, so 4 is also marginally acceptable. On the other hand, if it's less than 2, meaning 0 and 1, then the system won't be able to tell the difference between parts. Okay, so this is the Gage R&R nest study. Sorry, cross study. Now let's take a look at the nest design, the data for that. Okay, so you open Gage nest. Okay, so here, okay, so this is still the old data. We have the new data. Okay, so let's close this, close this, close this. Okay, so we can open from here. Okay, so you look at again after open the file, which is Gage nest. Look at the data. So we have 15 different parts, and we have 3 operators. Now, part 1, for example, part 1 is not only measured by Steve, not by the others. Okay, and the column 3 corresponding to measurement or response. Okay, so in this case we will use nest design because each operator have unique parts. Okay, so we go to stat, quality tool, gauge study, and gauge study nested. Okay, so the cursor is in the part of batch number, and we double click part, it goes to the box and operators. The cursor goes to operator, and we double click operator, and then the cursor moves to measurement, and we click column 3 corresponding to measurement, and then we hit OK. Okay, so this is the output for the nest design, and we also provide a screenshot in the presentation, and I discussed it, of the variance is probably due to Gage R&R. Specifically, it's due to repeatability, because each operator will measure unique parts, so there's no reproducibility here. Okay, so we can see from the graph, we haven't seen the number, but it seems the measurement system is not acceptable. Okay, now if we look at the response by part, you can see there's 15 parts, there are 3 operators, and there's measurement. So you can see the measurement is not good, right? There's 2 measurements, there's very large variation, so the measuring instrument is not good. But we cannot really tell that we don't by design we cannot evaluate the reproducibility. Okay, and a similar thing, if you look at the response by operator, seems that the mean is close to each other, right? But there's some variance, right? Big variance, same amount of variance, probably due to the measuring instrument. Finally, we have R chart and a bar chart, the X bar chart. They seem to tell the same thing. Okay, so we close this, and then now we also look at the numerical output. We look at the nest ANOVA. Okay, so we can ignore the ANOVA part. We can look at the variance component. We can see the total Gage R&R have about 82.46% contribution. So we said if it's less than 10%, it's acceptable. It's definitely acceptable. Less than 1% is definitely acceptable. If it's less than 9%, it may be acceptable. But if it's greater, it's not acceptable. And this is way above 9%. Okay. And similarly, if you look at gauge evaluation, you can see the study variance percent for Gage R&R is 90%, more than 90%. So we said if it's less than 10%, it's acceptable. It's between 0% and 30%, it's maybe acceptable. But if it's above 30%, we will reject the measurement system. So currently it's 90%, way above it, so we will reject it. Finally, if you look at number of distinct category, you see it's 1. So again, the system cannot tell one part from another, so it's not useful. So we will reject as well. Okay. Now let's take a look at regression. Okay, go to Minitab. Okay, so here is the data, the simple regression data. First we go to stat, regression, and then fitted line plot. Okay, and the response variable you enter cars sold. And the predictor variable, you enter TV ads. Okay, and you also can choose different graphs. You can choose histogram, normal, plot, residual versus fit. Okay, and OK. Okay, so it will give you a number of different graphs. Right, so the fitted line graph tells you the linear regression equation. So the car sold equals 10 plus 5 times number of TV ads, right? And the R square here is 87.7%, which is pretty good. It's called coefficient of determination. Okay, so we prefer large number, close to 1. Okay. And you can also look at the normal probability plot, histogram, and also the residuals. Okay. So let's close all these. Okay, alternatively, you can also use regression, fit regression models. Okay, so in this case, it's more general because you can use you can have more than one predictor. Okay, or more than one independent variable or variable correlated to the cause. Okay, so there are several options you can choose. Okay, and the graph, for graph you can choose histogram, normal probability plot, and residual. Okay, then hit OK. It will give you the same thing, right? Okay, again, because this is just one variable, so you are able to get the fitted plot. Okay, so this is the output in the Minitab, and we discussed this. Okay, so now let's do multiple regression, linear regression. Open the data, regression multiple. Okay, and we look at the data. So the first column corresponding to the response variable, which is heat flux, and then the second column corresponding to east, west, north, south, and the noise. Okay, those are the three predictor variable or variable related to the courses. Go to stat, regression, fit regression models. Okay, so we delete this, and the response is heat flux, and the continuous variable is east, south, and the north. Okay, you click OK, and then you can look at the output. Okay, so the regression equation is significant because the p-value here is close to 0. Now if you further look at all the four coefficients corresponding to the intercept and the east, south, and north, you can see the intercept and the south, north, they are close to 0, meaning that indicating that they are significant, meaning that they are not equal to 0. On the other hand, the east, the coefficient corresponding to the east, is only 9.2%, the p-value. So if you use level of significance of 5%, then you will fail to reject the null hypothesis. You will claim that the east is close to 0, the coefficient. Okay, so you can verify this using from the regression equation, which is down in the bottom. You can see the coefficient corresponding to east is 2.12, so it's relatively close to 0. Okay. Okay. Finally, let's see the correlation, and again we use this TVS data. Go to correlate. Go to basic statistics, correlation, and delete. So our variable one is the first one variable is TVS, one variable is car sold, and then we hit OK. So you can see the output here. The Pearson correlation is 0.937, and the p-value here is corresponding to 0.019. So if your level of significance is 5%, this is significant. So we reject the null hypothesis, which is the correlation coefficient equals to 0. Okay, so thank you. Again, if you have any questions, please feel free to ask me or the TA. Okay, thank you.